So hi, I'm John Frank with the United States Forest Service Rocky Mountain Research Station here in Fort Collins, Colorado. And today I'm going to take you on a virtual field trip of the GLEES AmeriFlux site in southeastern Wyoming. And we're starting the day here at the Forest Service Research Laboratory in Fort Collins. And before I go into the building here, since we're under COVID protocols, I'm going to have to mask up. But we're just going to hit the road in a few minutes. All right, we're officially underway. Distance to GLEES is about 100 miles, and our travel time is about an hour and 45 minutes. Right now I'm just driving through Colorado State University as I'm leaving Fort Collins, and I'll point out a few things along the way. So here we are crossing the border into Wyoming, leaving colorful Colorado and heading to Wyoming for the day. There's our welcome to Wyoming sign. This stretch of road here at the Pumpkin Vine Summit is notorious for terrible weather, and one time I was here with Stephen Chan going to the AmeriFlux site, and we probably passed a half dozen semi-trailers blown over in the wind. I once saw a t-shirt that said "Welcome to the Wyoming Wind Festival, January 1st through December 31st," and that seems about appropriate for this part of southeastern Wyoming. As we make it over the summit, the mountain range in the background is the Snowy Range. That's our first view of GLEES in the background. We've been on the road for about an hour, and we're only been in Wyoming for about 5 minutes. So GLEES stands for the Glacier Lakes Ecosystem Experiment Site. It's here in the Snowy Range of southeastern Wyoming, and most of the field sites at about 10,500 to 11,000 foot elevation. The Forest Service started collecting meteorological data at the site back in 1987, and we started collecting eddy covariance data in 1991. Centennial, Wyoming, population 270. It's 8,076 feet above sea level. Watch out for the highway patrol here in Centennial. All right, well, I've been driving through Centennial for about 25 seconds, and I am now leaving Centennial. This is the entrance to the Medicine Bow National Forest, and immediately we're in trees. In the background, you might see a lot of the gray standing trees that were killed mountain pine beetle probably about a decade ago. We're at about 10,000 foot elevation here. You can see the end of state maintenance in winter sign I just passed. So in the winter time, this is where we have to park and drive a snowcat the rest of the way to the field site. This is where we exit on the Forest Service Road to GLEES. Park. Well, welcome to the field site, and I'm just going to take a few steps into the trees and show you the tower. And there it is. So before the beetles, when I started working here, this was kind of typical for the understory of the forest, pretty barren, with the big spruce trees and fir trees overhead. But very different as I kind of pan through the forest, you can see this is a tremendous amount of understory vegetation growth in the last decade. But this is the tower. As you can see, it's set amongst a lot of dead spruce trees for the overstory. The tower is about 22.5 meters to the eddy covariance, a little taller to the very top of the tower. It's 12 levels tall. This is the shelter at the base of the tower, and this is the site back in 2001, I think, when I had a bear eat my trail mix. And I'll give you a quick tour. Just a little 10x10 shelter. You can see toolboxes, our Picaro laptop, which collects most of the data. Today, I am actually working on resolving an issue with our Lycor 7200. I'm filming this in July, so hopefully by the time this is shown, I've solved my problem. You can see our Lycor 7000 for our profiling system and our profiling manifold, and some nice windows and a fairly pleasant view out into the forest from the shelter and the base of the tower over here. It's kind of fascinating. This is the tree right in front of the shelter. And as I zoom up, you can see all the sap coming out of this spruce. This tree has probably been attacked pretty heavily by a spruce beetle. You can actually see the sap of the pitch tubes right there where the beetles attacked and the tree's fighting. What's kind of remarkable is this tree actually lived. And as I go up, you can see all the needles. Spruce trees can live for a couple years under duress, and then this one actually survived. So a fair amount of trees. This one's probably 10 centimeters in diameter, so pretty small tree for beetles. One of the things I tell people is that after the bark beetles, the future forest is already here. Now these trees are generally subalpine fir, which have their own beetle problem, but not so big of a deal here. But a lot of these subalpine fir trees are 200 to 300 years old. So I'm going to climb the tower here. The tower is 12 levels tall. And one thing you notice is that for each level of the tower, we have kick rails, we have handrails, and even the ladders have handrails. And you can see we have a hatch here locking to keep the general public out. What that means is that we can climb this tower and we don't need to wear safety harnesses as long as we stay within the confines, because according to OSHA, everything around here would count as fall prevention. This is the lower eddy covariance system. You can kind of see it's kind of in a tight spot, but I'm about halfway up the tower, and it's kind of a mix of dead and live trees. This is about as tall as the living subalpine fir have grown. Here you can see the one that's by the tower, it's still alive, and you can see it's very top, which is pretty cool. And all right, I'm at 22.5 meters above the ground, and this is the main eddy covariance system and the main eddy covariance control boxes. And you can see the trees to the east of us, a lot of dead spruce and a few living fir, and more control boxes. And then cool view to the south. That meadow is in the dead center is where I had the old AmeriFlux tower that was 100 foot tall or 30 meters tall. And we have a view down to Colorado looking to the south. And you can see we have 4A net radiometer with EPLI net radiometers, and of course the CNR4 from Kippen Zone in here. National Park, and the Rewa Wilderness in the north. So this is the Snowy Range with some Mesimo Peak in dead center. You can see the road kind of in the cut here. This is all looking west of the tower. This road was kind of clear cut last fall, and this is the first year we're getting fluxes where we would see the effect of some of the logging, which unfortunately is in the footprint of the tower. To the north, it's pretty consistent spruce fir. You can see our new infrared temperature sensor, our RM Young wind vane, and the trees to the east. This may not look like much. You see the PVC pole there, and you see the soil respiration collar there. But this is one of our vegetation plots. You can see the tree tags. And we have a network of plots, probably 60 or so plots around GLEES that have been around, some of them back to the 80s, where we know things like the forest inventories and then understory plant inventories. These trees are actually growing at just phenomenally fast rates compared to their historic growth. And so they're also part of the story of the CO2 recovery and the carbon sink recovery at GLEES following bark beetles. As you can see on the ground, GLEES is very green, a lot of trees growing very well, but as you start to look up, it doesn't take much before you start to see dead trees. So you can see the cutting area they did last fall, and they thinned this part of the forest just about maybe a 30-meter swath. There's a remnant of the slash piles they burned this winter. We actually saw CO2 at the tower increase about 50 or 60 parts per million even at the top of the tower during the burn day. And so this is what we're tracking, the response to this little bit of a clear cut. You can see recreation in the area. And there's the car, and you can see our tower just barely poking through the trees.